In these presentations, we are going to discuss about the operating system operations. The basic operations are multi-programming and multitasking, dual mode and multi-mode operations, timer. So in this multi-programming, a single user cannot always keep the CPU and I/O device busy. So the multi-programming organizes jobs, so the CPU always has one to execute. A subset of total jobs in system is kept in memory. One job selected and run by job scheduling. When a job has to wait, the OS switches to the another job. So in this memory layout of the multi-programmed systems, the operating systems are process the scheduling process. So when the system is in free, so but more than one process are in the waiting stage, it process one by one. In this multitasking, a logical extensions of batch systems, the CPU switches jobs so frequently that the users can interact with each job while it's running, creating interactive computing. So it has to maintain response time and process the CPU scheduling, swapping and virtual memory allocations. So in this response time should be less than of 1 second. Then the each user has at least one program executing in memory process. If several jobs ready to run at the same time, the CPU scheduling is proceeded. If the process doesn't fit in memory, swapping moves them in and out to run. Virtual memory allows executions of process not completely in memory. The next one is dual mode operations. In the dual mode operations allows OS to protect itself and other system components. There are two modes, user mode and kernel mode. So the mode bits are used to represent which kind of modes are available. So here when the user is running, the mode bit is in the 0th mode and that is in the user mode. When the kernel code is executed, the mode bit is 1, it is in the kernel mode. So actually the transitions from user to kernel mode, the user process start the executions of the process, then it make a call. Afterwards the executions turn over to the kernel. Then after the executions completions for the system call, the functions return to the user mode. In that way, appropriately, the mode bit value is changed. Next one is the timer. The timer to prevent infinite loop. So timer is set to interrupt the computer after some time period. Keep a counter that is decremented by the physical clock. Operating system set the counter when the computer 0 generate an interrupt. Set up before scheduling process to regain control or terminate the program that exceeds allotted time. Some additional tasks are also handled by the operating systems. So there the process management is very important because the process is a program in executions. So it is a unit of work within the system. The program is a passive entity, process is an active entity. So the process executions, that's in program executions, is called as a process. So the process need resource to accomplish its task. So that resources are CPU, memory, IO files and initializations data also. So the process terminations record reclaim of any reusable resources. As a single threaded process has one program counter specifying locations of the next instructions to be executed. So the process execute instructions sequentially one at a time until the completions. Then the multi-threaded process has one program counter per the thread. So in this process management activities, it is mainly focused on creating and deleting both user and system process, suspending and resuming process, providing mechanisms for process synchronizations, providing mechanisms for process communications, providing mechanisms for deadlock handling. The next one is memory management. So the OS is also make an important role in the memory management. So when the small amount of, that is some short time durations is also essential. At the same time, the memory size utilizations to be very low, that to give effective results. So to execute the program, all of the instructions must be in memory. So all of the data that is needed by the program must be in memory. So memory management determines what is the memory and what is in memory when. So the optimizing CPU utilizations and computer response to the users. So the memory management main activity is keep track of which part of memory are currently being used and decided which process move into or out of the memory, and allocating and deallocating memory space is needed. The next process is file system management. So in this main activity is creating or deleting a files or directories, primitives to manipulate files and directories, mapping files into secondary storage, backup file onto stable storage media. Then the next main purpose is mass storage management. So in this big amount of data, that's usually disk used to store the data that does not fit in memory or the data, so that must keep for a long period of time. So in that time, the mass storage management activity is needed. So it maintain mounting and unmounting, free space management, storage allocations, disk scheduling, partitioning, protections. The next process is caching. Important principle performed at many levels of computer. So information is used copied from slower to faster storage temporary. For the faster accessing of data, this caching mechanisms is used. If we capture the information from the memory is an long time process. So if it is in the cache memory, it is easy to access, so the accessing time to be reduced. The next management process is IO subsystem management. So it is the responsible is memory management of IO, including buffering, caching and spooling. So general device drive interface and also drives for specific hardware device. Then protections and security. So in these protections, any mechanisms for controlling access of processor or users to resources defined by the OS. In the security defines of the system against internal or external attacks. The next main process is virtualizations, allowing operating systems to run applications within other OS. So it also follow the some other specializations terminologies like emulations, interpretations, visualizations. So here in the visualizations, the OS natively compiled for the CPU running guest OSs also natively compiled. Consider the virtual machine where running Windows XP guesters, each running applications all on native Windows X host OS. Then virtual machine manager provides visualization service. Then distributed systems, the collections of separate possibly heterogeneous system network together. The network is the communications path. The TCP IP most common for the local area network, wide area network, metropolitan area network, personal area network. This is the end of chapter 1. Thank you.